Good afternoon, everyone. Good afternoon, everyone. Did you have a nice evening yesterday?
Oh, yeah.
Yeah? I saw you were having a good time. I had a great evening. I thought that was a great place. So, are you ready to continue exploring the deployment of AI? Yeah? Great. So, on the program this afternoon, we're going to begin by looking at some opportunities in virtual reality and augmented reality. After that, we're going to ask the question to see how AI is driving computing. And we're going to have Atos and Toshiba Memory speaking on that. And after that, we're going to have a look again at the edge with Gear Falcon technology. Then we'll have a quick break, and at 4 p.m., Cedric Villani. Cedric Villani, who is an acclaimed mathematician, I don't know if you know him, he's going to be delivering a special keynote on meaningful AI. By the way, in 2010, he received the Fields Medal. The Fields Medal is actually one of the greatest honors that you can receive as a mathematician, and some consider it like a Nobel Prize for mathematics. So don't miss the moment at 4 p.m. At this point, we're going to get things started with Edgar Auslander from Facebook, who's going to give us an overview of augmented reality and virtual reality. Please join me in welcoming him. Edgar, where is he? There he is.
Thank you for the introduction. The agenda I propose today is to have just a few numbers about Facebook, to introduce the company, and then some perspectives on VR and then AR, and the roles that AI plays in AR and VR, and the opportunities presented by AR, VR, and the challenges associated. So a few numbers about Facebook. It's all about connecting the world at scale. There are 2.7 billion people using the Facebook apps every month. Facebook, Instagram, Messenger, WhatsApp. More than 2 billion people using one of these apps every day. In a single second of January 1st, 2019, through our servers flowed 58 terabit per second. That's the equivalence of all the information of the Library of Congress in the US in just 1 second. And 12,900 videos were uploaded in Instagram in just 1 second. If you were to watch them from start to end, it would take you 9 days. Something else here, see here the message was in French, some of you don't need the translation, but this is an example of another use of AI, 6 billion roughly translation every day. Here is the Facebook roadmap that Mark Zuckerberg, the founder and CEO of the company, showed at our developers conference, F8, 2 years ago. And what's interesting here is you see on the right side the main technologies that enable the products in 10 years from now. So the first technology is connectivity. We are looking at connecting more and more people to the internet, AI, which is pervasive in all products, and VR and AR as being some key technology for Facebook in their 10-year strategy. Now I'd like to talk about VR, and it's difficult to show VR in a 2D screen. You need to experience it. But I wanted to show this because VR is well known for being immersed in games, and we have like products with more than 10,000 games or educational videos, but it's also a way for people to interact. And being a social network, that's very important for us. So here is an example of an ad that we used in the US. So I'm sorry, it's a very US-centric ad, but you can see Adam Levine, who is a singer in the Maroon 5 band, and Jonah Hill, who is a famous actor in the US, and they are in their respective houses watching a live NBA basketball game. So here is. So here they are, and you can see their avatars talking to each other. So we see this future like sharing the experiences together in being immersed as if they were there together. So now I want to concentrate on the idea of bringing people together in VR, which requires a convincing rendering of place and ability to bring remote people to that place. So let's start first with a room. There are many aspects of making this vision work. The two main themes are sensing and reconstructing the real world in general and bringing virtual humans to that world. So reconstructing the real world is challenging but doable. You can have a scan of the place, and then it's digitized. When you have that, you can put virtual objects in the scene. You can change the carpet, you can change the walls, you can put also people and have a conversation in this real world, virtual world, sorry. There is here something important. It's like more challenging is to reconstruct world with mirrors, for example. And here, believe it or not, the left side is a video of the room, and the right side is a 3D reconstruction of the room. And it's tough to see the difference. There are some artifacts here you can see around the mirror that is on the couch and the lamp, but it's pretty convincing. Now I want to concentrate on the idea of bringing people together in VR, which requires a convincing rendering of place and the ability to bring remote people in that place. So here is a picture of our CTO, Shrep, and you can see a few years ago he appeared on stage and the avatar was just a blue rendering of his head, and then AI enabled to have a creation of an avatar more realistic with generating avatar directly from photos. But this is still cartoonish. So here is what we can do. So the picture on the left is the real person, is a colleague of mine at Facebook Reality Labs, and then on the right was his avatar. And when you have that, then you can have this type of things happening where someone has a helmet and they both communicate, but they see each other. See the person sees the woman and the woman sees the man on top, and they can have a conversation. So in the future, instead of using video calling, people can have conversations like this using their VR helmet or their AR glasses.
I do yoga, and then I do yoga and boxing. Yeah, it's a nice contrast. What kind of yoga do you do? I do hot yoga.
So here, what's interesting is that there is no camera to film the lips and how this works. So via AI, there is just with the audio, the lips are being animated and look natural. We can also we have research on simultaneously scanning and tracking the entire human body in the movement using a single sensor, and we can reconstruct the entire body with the clothes virtually, and it looks very realistic using models of your skeleton and the muscles and so forth. So here is an example of what we've shown at F8 recently. Oh, I missed that animation. Sorry about that. Okay, that one didn't work. Oh, here. Let me do it manually. Still doesn't work, so we'll miss that. This is an avatar with clothes on. That's all simulated. Now going to AR, you have all types of AR. You have the ability to have audio AR that I show on the left, where your reality is enhanced by just sound with an assistant, for example, like in the movie Her. Then you have 2D AR, which is augmenting your reality on a phone, for example, or on monocular smart glasses. And then you have AR with full 3D, and that presents the most challenging design challenges. If you want to do industrial AR, the style doesn't count, and it doesn't matter if the battery lasts for just 1 hour or 2. But if you want to do consumer AR, style matters, and all-day wearable is typically required, which is much more challenging. So if you want to do AR with phones, that's doable today. Here is an example of what we do with our technology called a Spark AR, and that's available on phones today. What about having glasses that would do a lot of magic things, like giving you superpower or enhancing your memory and cognition? Imagine, for example, they could feed your key statistics in a business meeting. That's what I show on the left. Or they can translate slides on signs on the fly, or prompt you with a name when you meet someone and you don't remember the name. Of course, this presents also interaction challenges because, for example, imagine I wear these glasses. I know a few of you, but not everybody, and then tons of names would pop up, so that's not acceptable. But I'm sure that this can be resolved. There is also other applications in AR superpowers. Imagine it could help you decide healthy food choices, which is something I really need. Or what about seeing if someone has fever? Or what about meeting someone in a bar and you want to focus on just what she's saying and eliminate the background noise? So that's something that is possible. Now that I've presented what is VR and AR, I'd like to focus on, because this is the theme of the day, on AI. The first use case, use of AR is contextual AI. There you can have, in the example I've shown already, the contextual data in a meeting. You can have answers to the question, why is this baby crying, or things like that. So this is viewing AR as actually contextual AI. You can also have another use of AI, which is scaling solutions to consumers. So in the example I've shown before, where you had on the left a real person, on the right an avatar that looks like him, that took a lot of cameras and microphones and lots of computing power to really make that happen. In the future, you can use probably AI to diminish the number of cameras you need. I just scan my body like that with a single camera, and I have an amazing rendering. That of course requires a lot of data sets. I can also use AI to enhance computer vision and this complex reconstruction. The other use is the possibility to add convenience and save time and money. In the example I've shown here, you have on the right, we each have a different body. The ears have different pinna. The shoulders and the torso are such that to really have a binaural sound that is well reproduced, ideally you would need what's called the head-related transfer function of your body to really make the virtual sounds or the sounds look as if you are in the room live. For that, you need this HRTF machine that is shown on the left, and you have to sit there for an hour and not move. With AI, you could eventually take just a few pictures of your torso and the ear, and voila, you have your HRTF without having the pain and the cost of the HRTF machine. The opportunity and the challenges presented. The opportunity is basically, you see in the 50s it was the computing area. In the 2007 when the iPhone was introduced, that's more like the mobile area. And we envision the future to be AR being the next communication and computing platform. That's helped, of course, by Moore's law, but there is much more than Moore's law to make that happen. There are several challenges in optics, in computer vision that cannot be solved by just throwing a semiconductor at it. You need new sensors. You need totally new types of technologies that don't really exist today. So I've here listed a few, and you need also very low power implementation of these very challenging problems, and that's why we work with people that are in the room and with the Leti as well. A lot of innovation is needed. I singled out silicon, maybe because I have experience in silicon, but there is a lot of challenges in terms of light source, in terms of optics, haptics even. So we are looking for partners. Actually, that's what I do. We do technology partners. We have about like 500 startups and hundreds of public companies and research centers we work with to make this happen. So we cannot make it just by ourselves. So my call to action is let's make the future together, and you can contact me at edgary@fb.com. Thank you.
Thank you. Thank you, Edgar. Make sure that you take advantage of the opportunity to go see the Leti exhibition area if you haven't already done so. Who has been there already? Good, good, good. Who has seen all 45 exhibits? Yeah, liar. Oh, you walked around like that. Okay, okay, really fast then. Okay. Well, I checked out the thing for the relaxation yesterday. You know, you put these electrodes on your head, and then you sit in the little seat there, and you get really, really relaxed, and you see what percentage of relaxation you're able to get to. Did you try that? Yeah? Did that work? Good. Well, maybe you should go back then if you're feeling a bit stressed. Good then. Moving on. We're going to ask one very simple question. What do you need to make AI work for you? And to answer that question, we're going to hand over to Rémi Barbarin, who is the head of R&D at Atos. Give him a big, warm welcome.
Good afternoon, everybody. Thank you for having me here. So, topic today is what do we need to make AI work for us? So, at Atos, as all of you, we are deeply convinced that AI will contribute to shape the future. But we approach it with extreme pragmatism. Our obsession is basically to make sure that AI will bring benefits to our customers' business in a tangible way. So right now, AI is at the peak of expectations, and I guess you all have seen a Gartner hype cycle, you know, and they call that the peak of inflated expectations. So we all know what that means. Yet, very fast progress is made each year, and some AI technologies are today more efficient than humans in some neurocognitive domains, such as massive data analysis or complex strategic games, such as chess or Go, image recognition, for instance, in medical diagnosis. And this leads sometimes to the vision that AI may be a next step in an evolution path, leading from slow biological to fast cultural and then ultra-fast code evolution, fostering a transformation of our society and even of ourselves as human beings. All this leading ultimately to the singularity. So, will we be augmented by AI? And this is a debate that we have on TV, in the newspaper, and it's both fascinating and a little bit frightening. But we are still very far from that. It's still science fiction. As we all know, AI remains today very basic compared to human intelligence. So back to reality. In fact, we think that the reality of AI today, the impact on business, is already as disruptive as the science fiction dream of superintelligence. So why? Because the rise of AI today is basically the fourth and most disruptive phase of digital transformation. First phase was back in the 60s and 70s with mainframes. So for the I'm a bit too young. I didn't experience the arrival of mainframes, but yet it led to a disruption in business management. The second phase in the 80s and 90s with PC and web led to a major disruption of individual and collective productivity. And the third phase, at the turn of the century with cloud and mobile, led to a disruption of business with e-business and mobile business. With the rise of IoT today, digital crosses the last mile to invade and power things, power devices. The impact, the exponentially huge numbers of connected devices everywhere, wearables, devices, autonomous vehicles, smart homes, smart factories, smart grids, generating an immense volume of data to be analyzed and acted upon, all this requiring intelligent automation and therefore AI. So according to McKinsey, the smart machine age, combining IoT and AI, will become the foundation of the next generation business ecosystems, and they assess the economic impact to barely $11 trillion in 2025. And 2025 is tomorrow. So what's needed to success? Our vision is we need verticals first. Because the combination of AI and IoT, and basically notably the distributed AI, what we call edge AI, and you saw some pretty fancy example with my colleague before where AI is no longer only in the data center, where we have today the heavy compute power, but also in devices, in glasses, in your smartphone. So how to succeed? Today, everyone works on AI technologies. Today, we live in a world where basically banks and insurance companies have bigger teams of data scientists than tech companies. So this is essential, and we strongly contribute to it as well as ethos, both in services and in research and development, building the products regarding AI. Yet, we think that the heart of the battle will be in applications. So how can AI bring value to the business itself? Basically, we work with our clients to leverage AI on their core business issues. So we have here advanced analytics for operational optimization, predictive maintenance. So for instance, we make software that will predict which part of your data center will fail next. That's something we build currently in our Grenoble laboratories. Virtual assistants that you already are starting to see on many websites. Robotic process automations by picture analysis. Knowledge engineering. Smart autonomous machines with the famous autonomous cars, drones, and robots. And we work on all those topics I listed. We work on them on all verticals with multiple use cases that we implement with our customers and partners. So for instance, we have a few highlighted here. We are powering the Europe's largest genomic research institution, such as the Genomic England, with their 100,000 Genomes project, and they benefit from the high-end analytics and AI system to accelerate their research on precision medicine. We also support one of the leaders in clean energy, Fortum, leverage our AI to prevent energy generation outage, but also optimize service to customers for electricity, heating, cooling, and resource management. We also provide AI-powered prescriptive security for the Olympic Games, and as you know, this is basically the largest event worldwide with an audience of 4 billion people. Being the largest event worldwide means one thing: you're also the biggest target worldwide for hackers. So prescriptive security powered by AI is basically using AI to detect abnormal behavior and predict attempts of fraud and hacking. We're also helping Coca-Cola revamp their sales and logistics and engage better with their customers. That's with millions of smart coolers, smart shelves, smart soda machines, smart delivery trucks. That's a lot of smart devices. And on the other end of the spectrum, we are supporting the French government create smart homeland right here. Homeland security in France, so that means military intelligence, operational command, smart digital space of tomorrow within the Artemis project some of you might have heard about. So that's the major AI and analytic project of the DGA, local defense. We also Siemens' main partner for MindSphere. And MindSphere is the cloud-based IoT operating system that is basically connecting dozens millions devices, plants, systems, and it's currently powered by our supercomputers. And lastly, we have helped AXA Insurance propose a new innovative service to its B2B customers with connected fleet management and pay-how-you-drive car insurance scheme. So maybe you heard of that because it made the news, but basically, good drivers pay less than bad drivers. What does that mean? That means basically they reach 24% reduction in claims, 12% reduction in fuel consumptions, and an upgrade of 10% of car resale value just because there was an incentive for good driving behavior. And that's a few of the 1,000 projects we are working on today and that help develop AI. So, what's also needed to succeed? Well, we need a little bit of technology here. New technologies, especially to handle the exponential growth of connected devices and generated data. I mentioned that a little bit earlier, but basically within the coming 6 years, we'll see the number of connected devices multiplied by 3. And the amount of produced data by these devices multiplied by 5. This is going to completely redesign the landscape of IT because basically data centers, as we know them, they won't be able to host this data. So a lot of this data is going to be hosted in the devices themselves. So it will require local data handling. And while today 10% of the enterprise data is created by these devices, we expect that tomorrow that will be 80%. Tomorrow being 2025. So we call that a little bit provocatively the post-cloud era. And okay, don't get me wrong, the cloud is not going anywhere. It just means that we'll need more than ever vast hybrid clouds to host a large part of this data, but still we'll have to handle all this data in the devices. Beyond technologies, we need to be able to deliver AI at scale, and that means new architecture. So we are not, I know Atos has a reputation for being an integrator, a service company, but we're also a tech company. So that means we are building on hardware, we are building on publishing software. And we are also strong actor in quantum computing and high performance computing, but also in edge. Last month, we launched the most powerful edge servers in the world. So that was quite an achievement for us as the Bull Sequana Edge reached the market. And just like the CEA-Leti here, we're also a strong contributor to the European Processor Initiative, which we believe is something absolutely strategic. So in terms of architecture, at smart platform level, we contribute to the software stack with our partners, Google, Amazon, Siemens, and Microsoft. What does it mean? We provide something called Codex AI Suite that is also made by some folks here in Grenoble. And this has 3 major aspects. The first thing is the Codex AI Suite is an end-to-end fast development of complex enterprise use cases because we know that today simple AI use cases don't exist anymore. We need to combine machine learning with deep learning analytics and data management, and we need to deliver complex and accurate use cases at scale. What does that mean as well? That means that we need to be infrastructure agnostic. Today, researchers are realizing that supercomputers previously leveraged for simulation are very interesting for AI. That means you might be able to train your models on a supercomputer, benefit from this immense power, burst that on the cloud because you need a little extra compute power, and then deploy it on the edge because you'll need your models to work on, I don't know, maybe Facebook glasses, for instance. And lastly, Codex AI Suite allows you to be basically framework agnostic. So enabling advanced usage of all kind of data and all kind of frameworks, such as, for the geeks here, TensorFlow, Keras, PyTorch, and Caffe, among others. And recently, we completed that with the acquisition of Syntel that has brought to our clients the advanced capabilities of Synbot's robotic process automation, which I mentioned a bit earlier. So Our vision is that success will come from the capability to provide end-to-end business-driven AI capabilities, from infrastructure to applications, from data center to cloud to edge and the IoT devices. That's what we call hybrid AI, and that will combine the traditional HPC computing, the emerging quantum computing, all types of AI technologies, statistical, symbolic, supervised, unsupervised, as well as traditional AI and simulation. This is what we strive to achieve with our customers and partners. Yet there's this security issue, a tiny issue. So we are talking about an exploding number of devices, and that means security must be everywhere. An exploding number of devices means an explosion of threats with new cyber criminals, new vulnerabilities, and an increasing risk impact, because think about it. Hacking into an autonomous car is not exactly the same impact as hacking into a website. You can create much more damage. And hacking into a connected nuclear power plant is even worse. So because the thieves today are starting themselves to use AI tools and AI technologies, this is why we try to make sure AI is at the heart of security, especially for IoT. So we are among the pioneers here with Google, where we partner to provide software that will assist the security personnel in the PSOCs to identify abnormal behaviors. That's what we call behavior analytics. So basically, being able to detect a threat before or while it happens and not afterwards. Okay, so how do we achieve that? Our strategy here is about open innovation. Because to us, as I said, it's just the beginning of AI. So truly leveraging AI will require business-driven use cases, new technologies, security. This I mentioned already, but also this collaborative work. So engaging, we have the chance to have a pretty strong community of scientists and experts in ethos that we engage with our customers and partners. And we use radars and insight on emerging trends per vertical, leveraging multi-billion-dollar investments from the partner ecosystem, and that means Google, Siemens, Microsoft, Amazon, SAP, Oracle, Cisco partnering with us. On our side, we have a 300 million investment in research each year, but also some pretty ambitious project. As you might have heard, we are building right here in Grenoble a European-scale AI research center that will emerge from the ground in 2021. So that's one of the most ambitious projects we have in the coming years. And we practice in-depth co-innovation seminars as well as hackathons, design thinking AI labs, and fast proof of concepts within our labs. So that's why also I'm particularly happy to speak at Leti today, as we've been working with Leti for years, and we are involved in many joint projects in ER, Exascale, and the European Processor Initiative. So let's grow together. Let's co-innovate. We know very well that AI is so vast, nobody will be able to grasp this field alone. So it's a huge opportunity for co-innovation. Would you like to test new idea, explore new use cases or technologies? We offer BTIC. So those are Business and Technology Innovation Center. We have one in Paris. We have one here in Grenoble. And you can experiment AI with us within our Ethos Google Labs and experiment your own software on our supercomputer infrastructure, or even edge computers, or quantum computers. So let's stay tuned. You can follow our blogs. Our scientists and researchers are publishing a lot each week regarding AI, the latest breakthrough on quantum and edge. And we are pretty convinced this will power the future. Let's make it happen together.
Thank you. Thank you very much, Rémi. Now we're going to move on and continue talking about the latest innovations in devices, process, and system technologies. Our next speaker is Mr. Ishimura. He's the Deputy Director at Toshiba Memory. He's going to speak about the big data era, storage capacity, computing performance, and with a special focus on low power consumption. Please welcome him.
Thank you. Okay, so yesterday and today we had many AI talks. Today I'd like to share with you what the memory company is doing and thinking regarding the AI. So the memory is a key component for the current computing system. And people know maybe the evolution in the memory technology may help, but today I just focus on the non-volatile memory, how it can do for the future computing. So in the past, this is the photo of the 2005 at the St. Peter's Square in the Vatican. The people are waiting, the Pope is appearing. 8 years later, exact same location. You can see the significant difference, what happened. So many people, they carry the smartphone or the tablet to taking the picture or the movies or for the Pope. So we call we world in the digital age, and many people that hold the digital goods and the generated data. Actually, the people that generated data. What happened now? This is one of the example of the smart fab. Actually, this is our Yokkaichi operation. By the way, Yokkaichi operation is the world's largest single fab for the non-flash memory. So our fab has some kind of automated transport system. We are using system to avoid the congestion of the wafer handling and also try to find the efficient way to transfer the wafer to the next tools. Not only controlling those automated transport system, but also each tool that generated the data, like a process tool, like etching, the lithography, and the deposition, and also the inspection tool, they also generated the data. And we use those data for the analysis, failure analysis or the inspection, and also sometimes the control the process tool. In some case, we are predicting the maintenance time of each manufacturing tool. So these days, actually the data is a little bit old, but we generated more than 2 billion data per day. So we store all those data and utilize those data in real-time manner. So we already installed some AI-based the system for the inspection or the monitoring. So now the machine generates much more the data than the human. And as you can see in the previous presentations, already the generation of the data is close to the 200 terabytes in the 2025. And most of the data stored in the server, the enterprise. But the amount of the stored data is less than the 10% of the whole generated data. So this is why we are keep expanding our fab capacity and also increasing the memory density because huge the requirement for the storage. But one of the issues for the current computing system is the energy efficiency. So the left-hand side figure shows the electricity usage for the data center. So it is predicted that by the 2025, the electricity, the usage for the data center exceeds 3,000 terawatt hour. And at this moment, 2019, already those data centers' electricity, the consumption exceed entire that of the France. This is a huge amount. The which component consumes the most of the power? That's the right-hand side figure shows. Still the CPU processing element and the DRAM and the storage consuming those powers. So the system, the bottleneck in the current system is because of the old von Neumann computing system. Just said that the memory war between the processor and the DRAM. If the processor accesses some data, or either the SRAM, cache SRAM, or the DRAM, it consumes more the energy. And to access the DRAM, the energy, the consumption more than 1,000 times that access to the SRAM. So what the processors are doing these days, most of the CPU time, let's say for the genomics analysis or the natural language processing, more than 80% or 90% of the computing CPU time consumes to talking to the memories, not for the calculation, but only for the talking to the memory. That means the memory, the data transfer time. So the requirement for the deep learning the system, for the example, for the inference, for the cloud, they store the huge data for the learning. And as I mentioned, they consume a lot of the power. And for the edge side, even for the edge side, let's say for the automotive, they need some the real-time manipulation of the data for the autonomous driving. So all those data should be stored in the car edge side, and all the manipulation should be done the edge side. And for the bio, the genome, the analysis, one-time analysis generates more than 1 terabyte the data. If the people would send those data, all those data to the cloud, it takes a long time. So then it's not efficient. And for the mobile, the gadget, because of the security and the privacy issues, these days, people don't want to store all the data to the cloud. Still, the people want to hold those data in the personally. So the edge side should do the more manipulation of the data and also the stored data. But those kind of the product also has a limitation of the battery. So the both cloud and edge requires an energy efficient computing system. So the question is how the non-volatile memory that can support this requirement. The computing system, so there are mainly the three types. So the von Neumann type, the currently we are using, and the near memory, and in memory in the future. Many people say that in future that we should move to the in-memory type of computing. However, there's a kind of the trade-off between the current system and the in-memory computing system. The current system has the less efficiency in the energy and the performance. However, they have a lot of the flexibility of the memory size and also the number of the application. So the in-memory type is completely the opposite side. They are very efficient in the energy and the speed. However, the flexibility of the memory side and the application is limited. So the first, I'd like to mention how the non-volatile memory can do the current system. So the system requirement, the current system, as you can see, the processor and DRAM, and also the storage. So the processor accesses the DRAM, and those latency is an issue. And another big issue is the DRAM access to the storage, SSD. The latency is 1,000 times the slower, bigger. So how to improve this system? The one way is just expand the memory space. We put more information to the DRAM in the area. And also simultaneously improve the performance of the storage, so the less the latency. That is important. The first, I'd like to describe what we are doing for the storage. So as I mentioned, the expanding the storage area is very important and desired. So this is a kind of the density trend of the non-volatile memory. So thanks to the 3D the structure, because we face the scaling limit of the 2D structure, we moved to the 3D the direction, and we kept continue the increase the gigabit the density per unit area. And recently, we introduced the multi-bit technology, 4-bit per cell the technology. By utilizing those technology, even if we use the same NAND architecture, we could increase the more than 40% the density by using this technology. But this QLC type, the memory, they really helped. If this QLC SSD can apply for the servers, it can replace more than 10 hard disk drive in the one SSD drive. And also, simultaneously, the power consumption at the idling, the total power is 1,000 less compared to the hard disk drive. So the SSD can realize very the form factor, and also the energy efficient server system. This is very important, especially for the edge application. So we can increase the number of the density by introducing the multi-bit technology. But how about the latency? Still, the non-volatile memory is relatively slow compared to the DRAM. So what we are doing is that to improve the latency is just apply the many planes for the non-volatile memories. The conventional NAND flash usually has 2 planes, but one plane has a very huge memory area. But we introducing the many plane architecture that now we call the XL flash. That enable much faster the data access and flexibility to manipulating the data. And this enables one or the more the older, the faster the access time compared to the current NAND flash memory. The other way is some kind of the integration of the tip. The conventional the NAND flash in the package, they stack 8 or the 16 up to the 16 die in the single packages. But usually they are using the wire bonding to connect each the NAND flash memory. But this caused the significant performance degradation because of the parasitic capacitance and the wiring. So we introducing the TSB, the kind of the chip stacking technology. This significantly reduce the I/O portion. We have only the one bridge chip for the I/O, and all the memory array can be stacked by the TSB architecture. This enables the performance, the enhancement, and so far we have more than 1 gigabit per second the data rate in the single package, 1 terabyte the NAND flash. And the power consumption is almost half of the compared to the conventional NAND flash. And at this moment, we are using the die-to-die the stacking scheme. But in the near future, what will happen is wafer-to-wafer the stacking the scheme. And by using that scheme, and we can stack not only the memory, but also the very complicated logic the ICs. Because NAND flash requires a memory controller. And those memory controller, now we are introducing some kind of the AI architecture. So in the future, those things will put in the one single package. So by changing the architecture of the XL flash and introducing the TSV technology, we can improve the NAND flash memory performance. But still, if we made the SSD drive, it still has some problem in the interface speed. Because of the power limitation, interface the speed capability, bandwidth, some limitation. So what we did at this moment is we just trying to introduce the multiplexing the signal, the control the system in the NAND flash, the SSD drive. So by using the PAM4, the kind of the architecture, 4 channel in a parallel, so we can realize up to the 25 gigabit per second the data transfer rate. This significantly improve the SSD performance. By combining those three new technology, we can significantly improve the SSD performance. But even if we are utilizing those technology, still the performance gap between the DRAM. That's why the people are seeking the storage class memory to fill those gaps. So there are a couple of the usage of the storage class memory to enhance the system, like making the high density the DIMM or some cost effective the DRAM that replace some the DRAM chip or the faster SSD. So what happened now is the one company already they're going to the mass production, so-called the 3D cross-point memory as a SCM. But unfortunately, there's still only the one vendors that are making this, and maybe some company may follow. But another possibility to be the storage class memory is the RRAM or the STT-MRAM. So both two new memories already implemented in the Foundry's embedded memories. So it's the coming, those technology, and maybe near in the future, they can be the candidate of the storage class memory. So at this moment, for the RRAM, the 32 gigabit technology already demonstrated. For the STT-MRAM, the 4 gigabit already demonstrated. So in order to be the SCM device, the challenge is how to increase the number of the density of those memory. So by introducing the storage class memory and also the XL flash, we can make this kind of the systems. And accessing the SSD, we can also use the accelerator to control the memory. That reduce the CPU, the workload. And those accelerators can also be combined with the SSD by the multi-chip, the packaging the technologies. So how about the in-memory type? So in memory, all the processing, the manipulation data will be done on the memory. So we also studies the in-memory type, the memory, and also found some of the issues. One of the issues is that usually we consider the resistive type, the cross-point memory for the in-memory use case. But the conventional system, if we apply, the utilization of the memory array is less than 10%. So the energy efficiency is much, much lower than the conventional types. So in order to improve those disadvantage, we need some software technique to improve the performance. So recently, we proposed the concept of the bit parallel kind of the architecture for the BNN. By using this architecture, we change the bit density from the single bit, the 2 bits, the 3 bit, and doing in the parallel. And thanks to such kind of the scheme, the execution cycles compared to the conventional one and the proposed one, it significantly reduce the execution cycles. So this really helps to the cost-effective the AI the system. So the memory company, is simply making the memory, but also we are some of the big user for the big data and the AI. So the memory is need to work with the DNN accelerator simultaneously with the software. Those kind of the collaboration is very important to enhance the edge AI system. So the conclusion is that in the current info explosion era, there's a huge demand in the storage. And big flash, non-volatile memory still plays a key component role and continuously grows the gigabit density. And by combining the XL flash and the QLC, the SSD improve the system performance over the DRAM or the hard disk drive. And for the AI system, not only the hardware, but also the software architecture combination optimization is really key. And still, the flash-based non-volatile memory can support in the coming edge AI system. That's all. Thank you.
Thank you very much. So at this time, we're going to move back to the edge with AI. And you're going to discover why MRAM might be the ultimate AI IoT solution. So at this time, I'd like to welcome Terry Tornga, who is the co-founder of Gyrfalcon Technology. Please welcome him.
Thank you. I'm so honored to be here. And good afternoon, everyone. GTI actually is only 2 years old. And 2 years old, I will show you what kind of progress we have made. And our mission is try to offer from edge to cloud. We target everything from the edge. And there's many applications I think people talking already. And we are the one trying to helping them make things become reality. Okay, company founded in 2017. Currently, we have 5 different offices in 4 different countries. Headquartered in Milpitas, California, Silicon Valley. We have an office in Tokyo, Kyoto, Japan, South Korea, Beijing, and Shenzhen. In 2018, we have a Tier 1 award, Silicon 60 class. This year, we already have an award, Best Practice Award. And that was a Northern American AI Accelerator Chip, New Product Innovation Award. Plus, we have a 33 article talking about our vision, our product, the way we offer to the customer. So together, only 2 years, we have 3 AI accelerator chips in production. Actually, number 4 just came out last month. That one's in qualification for the big customer. So maybe months later, they will be the one announce the product. And another big one will come out, announce products by end of this year. And we offer ecosystem of chip system and the tool to our customer for their AI application. And all our technology is 100% our own. Currently, we have a 70 patent award in process. And up to today, actually, we have a 19 patent award already. Okay, so what's the vision in the beginning, 2017? When we start the company, at that time, actually even 2016, at that time, most of people focus on the cloud only. And most of people working on the software solution, like algorithm model, most of people still talking about competition. I can get better accuracy than you are. My model is better than you are, okay, that time. So people just thinking about all in the cloud. We are the people say we have to focus on the edge. Why? Because most people, they are not, first one. And second one, challenge is the one you need to know before you're working on the product, okay? So I'll show you there's 4 very important challenges. Most of people, I think, up to now, they only talk about 3. Okay, the 3 they are talking about power consumption. We all know. You are using GPU for your training. You're wasting a lot of power because over design. Okay, that one's the general purpose for everybody. So for you, it's too much sometimes. Another one, how you do data management, data flow control using GPU, you know, it's not for you. Okay, and the algorithm model, everybody different. So people talk about these 3 is very important. But for edge, there's another one even more important. It's application specific. Why I call this one? Because edge application will be all different. Each one will be different. Okay, and the difference will be some like 2 years old intelligence. Some you need 5 years old intelligence. Some you need 8 years old intelligence. Because you want the device to do different things for you. So in order to attack this edge AI, very important things, you need to be flexible, okay? If you are flexible, every time your customer asking for something, you can deliver, which is the approach we are doing. Before, I think most people only talk about you have to have a hardware software co-design. Okay, otherwise hardware finish design later using software to take care of whatever problem you have. Okay, that's very very inefficient. But for us, we think you need hardware, software, and memory, all three in the same time design. Okay, in that case, you can have a very flexible performance. You can target whatever application you are talking about. So the approach we are doing is the first one, processing in memory. Okay, that one actually is a lot of people talking about already. Second one is so-called matrix processing architecture. This one actually is the one Tesla talking about. And we also working on this one, but it's a different approach. The last one is you have to have non-volatile memory. That's the one for the future. I think we all know. But the question is, so many different kinds of things. Which one is the one you should go? Because you need to make product today. You want to make money right now. Okay, you can talk about technology for 5 years, 10 years, 15 years. It's just talking. You are not making money. Small company like we need to do something right away, get the product out, make money. Okay, so how do we do this? Okay, later I will show you the non-volatile memory approach. So once you have these three, actually there's one very important thing come out will be you can have a size, power, and the intelligence level all independent to each other. Okay, as you know, most of design, when they design need requirement high intelligence level, they need more power. Size need to be bigger. Okay, then what's the point? It's too easy. So if you have some kind of design, you can make these three independent. Then your performance will be very flexible. Okay, same size, same power, more intelligent. Then you can attack whatever application you are talking about. That's our vision. Okay, the way we are thinking, making product. So our technology accelerator is using so-called matrix processing engine, using APIM, AI processing in memory, as I show in here on the left-hand side. There's a parameter memory, there's a ALU memory, ALU data control flow. So each MPE will have a 42 by 42 APIM inside. Each, total, the chip will have a 16 MPE. So total you have 28224 total max. So that's one design, 16 MPE. Another one can be 4 MPE. Another one can be 8 MPE. So depend on what you want. So you look this on the right-hand side, very flexible. Depend on your performance, depend on your energy, depend on your cost. Okay, we can offer something you want. Plus our technology advantage, we can offer people different chip, different board system. Then you can combine using this one to do whatever AI application you are talking about. And finally, right now we are offer people IP license. So you can use them for your SoC, whatever you want to do. Okay, so that's our thinking. Give customer as much as we can so they can working on their AI application. And 2 years, we have a 3 chip, which is top 3. The first generation, 2801, that one's a general purpose. We just want to show people our technology. Can they using the chip for their application? So that one will be using for example, tablet, PC, or the smart home appliance. So before 2017, I think you know, there's no chip available. So customers have nothing to do, can design in for their product. You need to make something else so they can start to design in. And AI is a brand new thing, as you know. Everybody have different data. Everybody have different application. They need chip so they can play around with whatever application they are thinking about. So that's the 2801, delivered in 2017. Second generation, 2803, that one's actually performance even better. And good thing about 2803 is that you can do multiple chip with this button PCIe acceleration card. So actually you have a multiple chip. The performance is good enough for your data center. So we are doing something from edge to the cloud. And we also offer this evaluation kit and also M.2. This one can be multiple chip with the 2801. So there's a mixed match for people's application. And the middle one, 2802, that's the one I will talk more. This one is, I will call this industry number 1 with the embedded MRAM, 22 nanometer from TSMC. Okay, why this one so important? Because the MRAM, I think most people think that one still not mature. Okay, if you know how to use in non-mature technology, but you make a product out, it work, I think that's more important than anything. Okay, so that one I'll show you the data later on. We also offer this USB play plug, so you can plug into your notebook, plug into your workstation, and do whatever your AA project. Another one is we offer this one so-called Play Fi. It's a Wi-Fi box. So this one, good thing about this one is you can pair with your phone. So your phone is a non-AI phone, become AI phone. Your watch is non-AI watch, become an AI watch. So in that case, actually offer people a lot of flexibility. You can start to do whatever AI project you are thinking and the application. We also offer this development platform, like how we do the data training, model training, SDK, API, and model transfer. Because you know, most of people still using GPU, CPU to do whatever training using their data. We want them to using this one transfer, then it can be used inside our chip. Okay, the last one just that's very long term. We hope eventually someday everybody can involve this training together. Okay, that's a network training. That one maybe I won't say too much right now, but that's a long term, really huge market too. Okay, let me talk about 2802 since this is the industry first one. When we design this one, we are again hardware, software, and the MRAM all designed in the same time. Not like other people, like the left-hand side one. Typical, I think people design AI engine. Then they're using whatever MRAM available from other people. Then they combine these two, just like people using SRAM. Combine, then they got an AI chip. The way we are doing actually, we are design AI chip, AI core plus MRAM peripheral in the same time. In that case, MRAM array can be anywhere. You can come from Samsung, you can come from TSMC, you can come from Global Foundry. You can come from many, many different places. Okay? And in that case, you make manufacturing much easier. Okay? You become very flexible. Okay? And that's the reason why, if you compare the table on the right-hand side, GTI's embedded MRAM compared with other embedded MRAM, compared with RRAM, I call that one still R&D, and the SRAM. Okay? One thing AI memory is, in order to do this parallel processing, memory need to be distributed, okay, everywhere, okay? Every time you do this distribute, if your design is lousy, chip become very big, power become high, okay? So the way we do, actually, we can take away this problem, so we can do much better than other people. In the same time, we can enhance the endurance 3 order. We can double the speed, read speed, no problem. We can have a 20 to 50% power lower than other solution, okay? And we think that's the way for the future. And why I say this one is a work, because as a small company, startup, you only have 6 people, 7 people. When I go there, talk to TSMC, why they need to care about me, okay? They need to see our vision, how we approach it. So then their R&D work with us. We got the chip out, and it's working. That's the way we are running the business. So by 2018, middle of 2018, only 1.5 years, we got this industry #1 production AI chip out, called the Lightspeed 2802M, with embedded MRAM, 22 nanometer, first in the whole wide world. Okay, performance compared with 2801, we can have a 9.9 TOPS per watt. It's a 22 nanometer ASIC, 20 to 50% power saving compared with all other solutions. In the future, okay, we offer to our customer, you can have up to 10 nanosecond read speed. Actually, recently we show we can have up to 5 nanosecond read speed. All depend on the application. And the TOPS per watt can become 30. Okay, so way better than anybody else. And no power leakage. Why no power leakage is so important? Because when you are not using the chip, you are not losing the power, not like other people, okay? And the other one, very important, this one is if you put this one into your smart city, smart home, Someday there's a natural disaster. Someday there's a power glitch. All your data disappear. So each one you need to reload. Otherwise, the sensor doesn't mean anything. This one, no problem. Okay? And another nice one, okay, I forgot to mention one thing. Very important, we only talk about local. We are not talking about cloud. Okay? Everything's local. Local means you have a lot of constraint. So in order to have a high performance, you really need to consider everything. And local, good thing about this one is you keep your data. Your data is not in other people's hands. You can give the data to other people, that's up to you. But this one, just you have an option. You keep the data to your own. And this one actually shows most of people can only do one model, one AI model, one chip. This one can be multiple model, one chip. So-called one chip, not stack chip, one chip, just one chip. Okay, and very flexible. So again, I just compare all the performance. Okay, sometimes you hear people talking about their solution, but unless they talk about everything, otherwise it doesn't count because it's not a product. Okay, so let me come back this one more time. If you know the memory, we embedded inside 40 megabytes, which is huge. If you go this one to the foundry, I think foundry will tell you, say, yield will be lousy, but we are okay. 40 megabyte MRAM embedded inside can be more, depending on the application, depending on customer. Industry one only, local only, no cloud. Okay? We can have a voice ID inside. We can have a voice command inside. This one can recognize your face. Okay, you can do the image classification also. Think about this one. If you put this one into your robot, one chip, your robot recognize you, recognize your voice, recognize your command. Okay, so that's the application. Another one, put this one into your car. Okay, someday your car can recognize you or maybe your family, can recognize your family's voice, can recognize your family's some kind of comment. Okay, so the application will be many, many. I think that's the people working on the application will think about this one. And next one is it can be multiple ensemble model for this one to increase accuracy. Okay, this one maybe I should say a little bit more. Assume your first model, voice ID, accuracy is only 90%. Okay, then you worry about 10%. Something not right. Recognize the wrong people. What should you do? Okay, put another one inside. Voice command. Every time recognize people need to two things. ID and the command need to be right. So 0.9 times, so 0.1 times 0.1, that's a 0.01 error. So it kind of like a continue. Put more model actually became more and more accurate. So that's another application we think. And third one actually is very important. Most of people put the FC layer inside your CPU. And this one, because we have enough memory, you can move your FC layer into the chip. Okay, we say everything local, better. So this one even better. Okay, anything more? I think application people will think about this one. Okay, so we just open the door for people. This is a great application, I think, for Edge AI. So AIoT, for sure, that will be the future. Robot, autonomous vehicle. So many, many applications, okay? So that's the one we see is the future. Non-volatile memory inside give you flexible, okay? Okay, next one, I want to talk about another huge market. I think this one, a lot of people will be very interested in. By 2021, we know almost 70% of the data will be video. As you know, you watch the YouTube all the time. And those videos, if you cannot search your image, you cannot label your image, those data actually really is no use, okay? So if you have a way you can search, you can label, that would be wonderful. So this is a pain point within from the industry. So many data, no use. If you can have this one, label, search, there will be way better user experience, and the new business model will be gradually come out, okay, offered to all the customers. And currently, there's no solution. If you want to do this data mining in the video retrieval, okay, in the search, you require tremendous computing effort, resource, labor, huge, okay? So we compare our chip to whatever people are doing right now. And this one just show you using GPU, using CPU, process time, total time. We demonstrate to the MPEG 7 standard committed. We can have 16x faster than CPU, 1.9x faster than GPU. And if you look the top one, the way we are doing is a fixed point, VGG16. VGG16 is the one using for MPEG 7. And the model size, look that one, 59 mega compared with 4 mega. Okay. And the accuracy, precision score, 86.81, we are 88.95. So we are smaller, we are precise, we are way easy. Okay, and this one will be a huge one. And if you want to search the picture, that'll be way easy. Okay, so let me show this one first. So if you're using VGG16, no IP issue, and we are working with a committee right now. That's the hardware we offer to people. Okay. And that's the reason why by June 18, actually just last week, we make an announce we are ready, offer to our customer. Okay, I think that's all I have. Thank you very much.
Thank you very much. Thank you. So at this time, if you agree, we're going to take a coffee break. Yeah? And we'll meet back just a few minutes before 4 p.m., if that's okay, so that we can get started at 4 o'clock sharp. Thank you very much.